Hey everyone. Is Nathaniel, are you here somewhere?
Yeah, I'm here.
Oh, good. Have you introduced yourself yet?
Not yet. I figure I'd wait for everyone.
Oh, I think, well, let's just 37, 38.
That's fine.
I think we're accumulating. Okay, so can you guys see Nathaniel's pretty face there on the screen somewhere? For those who don't know him, he's our GA. I know you've heard me typing glowingly, and I think I mentioned him yesterday in class. He has a whole picture in the slideshow today, but um, one of the most published students of all time, like not just our department. I mean, dental school and everything. And so, um, but I will hand it over to Nathaniel to do some introductions and whatever else he wants to talk about.
All right. Hi, I'm Nathaniel. I'm from Grass Valley, California. It's about hour 45 minutes northeast of here, near like Auburn, if people know that. If you don't know California, I'm sorry. The yeah, I mean, I work with Jensen a lot with research, and I mean, he knows everything to know about it. So, and like, I guess just my advice is listen to him and take his knowledge and use it to your benefit, I guess. The labs I'm gonna get published. They're just kind of be, if you want to get them out of the way ahead of time, then you can, and you can send them to me. If you want to do them by the due date, that's fine too. I'll get them published probably around next week. At least the first and second one, and then maybe the following week the third and fourth, and so on. The Don't be afraid to reach out. Do you have my email on the syllabus, Jensen?
I'm sure it is. It's on there somewhere, and I think it's in the slides today.
Okay.
Um, but you can see his name on the Zoom box, and there's no numbers. It's just N underscore, and then the name. There's no like 56 or whatever.
Yeah. N_Holmgren at u.pacific.edu. Feel free to reach out. I do work nights, so I might be sleeping during the day. So if I don't get back to you, that's probably the reason. But I'll get back to you at least that night. Please don't be afraid to reach out. I'm more than happy to answer questions. The more you guys can just kind of reach out to me, the easier it is to kind of schedule things and put more communication between us. Is there any questions? Like, do you think people want to know either about me, about the labs, about the class? I mean,
Are you asking me or the class?
just anybody, if you or anybody.
So a little additional commentary on Nathaniel. He's like 6'70", but the least halfway to 7 foot person, the least intimidating version of that you'll ever meet. And so, again, don't feel afraid to reach out, or if you have questions. If my lecture isn't making sense, Nathaniel probably knows it, right? He probably knows the content that I'm talking about and can help shepherd you through. Whether it's running stats or just commentary on my commentary, he can be
Yeah.
really helpful. So, yeah, so feel free at any point to reach out to him. It is possible at some point in the semester, if the test is coming up, the lab is coming up, he might be just inundated with emails, and so maybe be a little bit patient. If 31 people email him on a day, it might not be that same hour that you hear back. But especially come lab time, I mean, he's going to be your go-to guy, and he knows his stuff. One of the best statisticians on campus, so we're lucky to have him in this class, and you guys are lucky to have him as a resource. And I think I mentioned this on Monday, the sort of all stars, the people who shine brightest in this class, we can pick you up on the research team and start getting you published by the end of the semester. Publications don't come out by the end of the semester, but start getting some submissions submitted. A little redundant, but so reach out to Nathaniel if you have questions. Does anyone have any questions right now? This is like one of those wedding moments to speak up. or not forever, but temporarily hold your peace.
Um, just wait. We can ask questions about the labs, right? Sorry.
Mhm.
Yeah, no, absolutely. Just,
Okay.
I mean, questions about anything. I went to UOP for my undergrad, so if you guys have any questions just about UOP, about life, feel free to reach out. I mean, I'm a good resource, and now that you guys have my contact information, use it. Yeah.
Okay. Just to make sure. So for some of the labs, they already have like a Word document already like set up for them and everything. But is it also okay if we end up having to like print it out and then scan it and send it back to you? Is that okay? Or
Yeah, that's
Did,
fine.
okay,
did,
just
did
making
I
sure.
upload the labs? I don't remember if I.
Oh no, it's just for another one of my classes. Just making sure.
Oh, okay.
Yeah, that should be fine.
All right.
Another one of your classes, is it what class is that?
Uh, health, uh, exercise, sports sciences. Like I'm part of Lab 4, for health, exercise, and sports sciences. Or
For 129?
yeah, 129.
Who's the GA for 129, Jensen?
Oh, I think there's three.
You have a lot of
Gigi,
teachers.
Stephanie, and I don't
For
remember.
lot four, it's Nicholas.
Is
Yeah,
Nicholas? Okay.
Nicholas. Yes.
Okay, yeah. So I just email him and say, is it all right if I can't do it through
Oh, okay.
Canvas? But if it's any of these labs, yeah, feel free just to send them my way, and just double check that I got it. If I don't send you, like, I'll send you a confirmation stuff when you guys submit stuff through me through email. And if I don't send that, just make sure I got it, because again, emails might get a little spammed during that time.
Okay. Thank you.
Mhm.
All right. Let's get started, and then I'll try to make it through the lecture. Can you guys see the screen?
Yep.
All right. Nathaniel's confirmation counts. So remember on Monday, I meant, this is me shouting on the screen there. Most people are so bored of history because nobody ties in practical applications. The lessons that come with history aren't connected to it. It's just history for history's sake, which is always boring. History and math, the two subjects sort of nobody likes. But especially in science, in research, whether it's medicine or human performance or anything to do with sports or the body, um, physical therapy, whatever, history teaches us just as much as the research coming out today, because everybody makes mistakes. We're making as many mistakes, probably more today than we made historically. And if we don't know about the nature of people's errors, historical errors, if we don't understand how they came to make those mistakes, we'll repeat them. Every mistake people used to make, 18th century, 19th century, 20th century, all of this summation of mistakes, if you understand how they came to pass, you'll be able to avoid that spot in the road. And then the successes, what types of creativity lend themselves to success. And so you can apply that same thinking to whatever today's puzzles are. And so the history is actually really important. We'll talk a little bit about history today. That's my office. I'm not going to be in my office, but there is Nathaniel. And as you can see his, 6-foot infinity height there. So, and the email address. So if you have um, a question about anything content related, and I'm not available, get in touch with Nathaniel. If you have lab questions, obviously get in touch with Nathaniel. He knows his material here. He's freshly climbed down from the beanstalk and is ready to help. Just remember the two books. Feel free to get one or both. ACSM's Research Methods is sort of health and exercise science, the top research book for that. Epidemiology 101, that one is epidemiology proper. If you're really interested in COVID and its spread, reading that book, or if you want to do an MPH, lots of jobs in public health. It's mostly running statistics, and you'll make way more money than I do. I was offered jobs as a statistician that's roughly double my salary here in my kitchen, or I'm in my laundry room today. But so you can, it doesn't take that much preparation and learning and work to get a six-figure salary if you're going into public health and public health statistics and especially medical databases, things like that. Hospitals have a lot of disposable income. And so today, we'll just do a little bit of chapter 1. It's at, pages, whatever it is, 1 through 8. So that's today. I'm going to go through this little map all the time. And so we're here. We have a few more days until we get to the exam, end of September 21st. Nathaniel and I are going to figure out a way to do that most effectively, how to do these exams. It's not really decided yet. It's not written yet. But at the beginning of every single lecture throughout the semester, I am going to just let you know what the readings are, what classes are coming up, content, but it's going to be about that fast. This is what used to be my favorite living author. He died in December 2011. I mean, it's been almost a decade now. But this political commentary voice, and I wish he were alive today to hear what he has to say about the coming election. But one of his famous lines, which I think he actually inherited from somebody else, was he was a total alcoholic. And so he would have these parties, and his line was, if you don't have a drink in your hand, it's your own fault, right? As in, the drinks are available. All of the resources are there. You show up to my house, you know where the drinks are, you know where the glasses are. Please help yourself. You have every resource you need to have a nice, enjoyable buzz to make that party go on, whatever, longer and louder, and for your role in it to be more enjoyable. But if you don't have the drink in your hand, this is just tea, then it's your own fault. And it's sort of the same thing for most classes, certainly this class, where all of the resources are available. You have access to me, you have access to Nathaniel, the specific readings are listed. The lab information is going to be posted. All of these lectures will be available. And so all of the content is going to be there. Just take accountability for how much studying you do. What you want to get out of the class is what you put in, essentially. So put that drink in your hand if you want to, have the buzz. Put the book in your hand if you want to ingest that material, the course material. So normally I ask people questions, but that sounds like a sort of waste of time of people clicking to unmute themselves. So science is basically knowing what we know today. We have come to learn a great deal of information about like astronomy and navigation and medicine and every type of related to medicine field, whether it's human performance or whatever. And physics and just every single field. We've come to know so much, and science is how we do that. This quotation, it sounds like gibberish, but it actually is pretty good. So science is a systematic study of the structure and behavior of the physical and natural world through observation and experimentation. Sort of too many ands, it's just conjunction after conjunction, but it actually is pretty good. So science is a very structured investigation of everything around you. It's not loose in its methods, right? It's very structured. It's not loose in its methods. And it helps you elicit answers that you can trust, right? Answers that are more meaningful. Historically, sort of before the advent of science, right, we had philosophy. And philosophy it's wonderful, right? It's a type of cogent thinking, right? It's sort of making the most philosophically of the world around us, but it's not experimentation, right? Philosophy is getting the best we can out of our hunches, but it is not putting falsifiable experiments to the test. And so science is this way of eliminating bias, running an experiment, and accepting the outcome. It's very elegant in its construction, but its communication, right? The way that it's conducted is brilliant, but its communication is generally horrible, right? It's like this, where, this person, let's say this is a student in class. I don't know, maybe he's a little old to be a student in our class, but so this is a student in our class, and he raises his hand and asks, what's a binomial distribution? And we'll talk about that. We'll get into binary, logistic regression and these binomial distributions. And so it's a totally reasonable question to ask, what's a binomial distribution? And often in classes, whether it's a statistics class or anything in the sciences in general, the complexity looks like this guy's answer, which is just, that's not what he's hoping to hear. He's hoping something is going to be expressed that is understandable, it's clear, he can walk away from that exchange knowing more about a binomial distribution than he did going in, and he just walks away feeling either pissed or bad about himself or hopeless or whatever. But if you think about a binomial distribution, bi means two, right? So it's I don't know, bicycle, there's two wheels, right? You're bipartisan, you're both parties. Bipedal, you're walking around on two legs. Bi whatever, bisexual, bi anything, fill in the blank. There's two of it. Nomial just means name, right? Name or a term. So in this case, there are two names or two terms and the distribution of them. So if you think of it from the perspective of flipping a coin, right? It's heads or it's tails. Flip 100 coins and you're going to get this series of heads, series of tails, and this sort of distribution accordingly. Or you win or you lose, it rains or it doesn't, whatever, these binary outcomes, these distributions like that. So throughout the class, I'll try to explain the undertaking of science with more understanding, where the process that you go about learning material, studying material, eliciting outcomes in an understandable way. The best example is music. Half of my analogies end up being about music in the end. The worst guitar players in the world, if you want to just show up at a coffee shop or walk around campus when we're not all viral vectors, and listen to people playing music, the people who do the most complicated sort of intent, they're making like facial expressions as they do it, guitar solos and the showmanship, those solos and those guitar licks and riffs and whatever belong to the least talented people. I mean, compare it to the most talented musicians in the world. It'd be hard to argue that the Beatles, right? Obviously that's the Beatles over here on the right. It'd be hard to argue that they aren't the most influential pop or rock or whatever genre, just all genres combined that's not classical. It'd be hard to argue that they're not the most influential and important band of all time and be taken seriously. And if you listen to a Beatles album, it's just the simplest songs in the world. I mean, it took like years before they hit the 3-minute mark in their songs. It's just simple melodies, very direct, and they weren't insecure about it. It's only insecurity that motivates complexity. You should be able to make the complex seem very simple, which is what we'll try to do in this class. But as you are moving forward in your own science and publication and experimentation, dissemination, wherever that leads you, try to be a Beatles member about it. Just be simple, be clear, be direct. Everybody should understand you. Everyone should be able to tap their foot and hum the melody. It shouldn't be this weird, complex thing that nobody gets. When I go to ACSM every year, except for this last year because it was, canceled. But when I go to ACSM, I watch student presentations, and in these student presentations, the most talented students are extremely concise. The most talented students are very cogent and direct and speak almost monosyllabically. Like you can understand everything that they're saying. The least talented, least bright, least educated, least prepared students are the ones that I can't understand a word they're saying. I have a PhD in this and I don't understand what they're talking about. And they're, 19 years old and they brag at the end of their presentation. They're like, oh, nobody in the crowd understood me. What I said was so advanced and sophisticated that nobody understood me. And they're like 19 years old communicating to people with PhDs and MDs. and nobody in the room understands them, one of these people has a problem, right? The person communicating in that way has a problem. And so work on simplicity, work on clarity, work on ease of communication in everything, right? This isn't just science. So this is on this slide. Here's the Bible. It looks like a picture of the Book of Monsters from Harry Potter, but that's been translated into, I don't know, 25, 2,600, a lot of languages. I don't think quite 3,000 languages, but languages are, you can't just put it, like, look at the number of flags in the world and that's the number of languages. That's not how it works. All these different indigenous languages, and the Bible's been translated into 2,500, more than 2,500 of these things. My favorite book, Picture of Dorian Gray, in its first 20 years, so ending in either 1910 or 1911, depending on which version you're talking about, is 14 different languages, and it's opening up. The idea of translations is opening up the breadth of communication, allowing more and more people to be able to be in on the understanding, to be able to benefit from that information. But there's a lot of languages, not just English and German and French and Spanish and Yiddish and whatever. There's a lot of languages that have an opposite goal, where it's exclusivity, right? So if it's Morse code and you don't want like enemies to know what you're talking about, you're in the war and you're using Morse code and like tapping, you don't want enemies to know your plans. If you're a baseball coach, you're tapping your hat and wiping your chest and touching your wrists and whatever, you look like Nomar Garcia-Parra taking the plate. If you're going through all of these movements as a coach, the idea is you don't want the opposing team to know that there's a hit and run coming, or there's a stolen base or bunt or whatever. You don't want that communication to be translated, right? You don't want that to be understood. There are a couple of examples of languages that are sort of, one is silly and maybe harmful, one is silly and probably helpful. Let's start with the harmful one. If you look at, when I grew up, the Berenstain Bears, and then Family Guy came out when I was in high school. And so but these, like, this idea of no girls allowed, which to me is a very weird thing. It's for, somehow it seems acceptable, because just imagine the word girls was replaced by a race, right? And how inappropriate that would be. It's such a weird thing that somehow culture at the moment accepts no girls allowed. But if you just swap that one word with another, it becomes one of the most hostile things you can put on the cover of a book. But people will make these little clubs and say, what's the password? Oh nay, Earl's gay, loud a, or whatever, like Pig Latin. It's gibberish. It's not real. Like ig pay atten lay. But it's a language of exclusion where people are just trying to, if you make up your own little language, or it's Elvish or whatever, it's sort of languages of exclusion. Maybe that's done with harm in mind or exclusion in mind, but in a silly way. But nobody would argue that Braille isn't helpful, but it is a language of exclusion. And so, every letter there are entire books written in Braille. And if I try to read it, close my eyes and kind of wipe my fingers across the bumps, I don't understand anything. It just feels like sort of metallic zits or something. I can't interpret that. Now, if the letters were convex or concave, I can close my eyes, touch it, and read, but I can't do Braille. So in a sense, it's a language of exclusion. My understanding is it speeds up reading, that if you are blind and you touch it, you can understand A faster than the, convex or concave lettering. But what I could do, I could touch the number 11 right here. Let's say it's an elevator. And I touch the number 11, I know where I'm going to go. I can push that button. I can't do the bottom half. So the idea of language of exclusion, now this one is to help a particular population. So it's a helpful language of exclusion. And it's not just pure. The person who is not understanding the material is not the person you have in mind, right? It is a method of opening up communication, but in a sort of exclusive way. Now think about science. And it's written in the equivalent of Braille, right? People read these journal articles and they have no idea what they just read. I often have to read a journal article 2 or 3 times before I get what they did. We all do that. Because it's very compressed and it's so dense and you're reading, and sometimes they're just poorly written. I'm an editor for several journals, and I get these things, and there's 1 or 2 out of 50 or whatever journal articles that I've reviewed, I've just accepted. Most of them are just like, people don't know how to speak English, and I mean native English speakers don't know how to speak English. And so what we want is for statistics and science and medicine and all these fields to be a language of inclusion, right? So the NIH, National Institutes of Health, this is the single biggest in the whole world, right? This is the primary research supporter, right? This is the springboard to curing cancer and HIV and coronavirus. And I mean, this is how it gets done. I just looked up this morning, and on the webpage this morning, it says $41.7 billion annually is what's going to fund research. I've worked on several NIH research projects before, but it's interesting that in the first 2 sentences, research for the people. The NIH invests about 41 whatever billion annually in medical research for the American people. It's by Americans. It's not even by Americans necessarily. It's international as well, but it's not really for people if only the scientists understand it. I mean, it really is Braille for scientists, the way these things are written. You can't just post a journal article on Instagram or Facebook or Twitter or whatever and have people read it and understand it. It has to be translated by the media before anyone understands what the hell it's saying. And so the goal for everyone in this class, if you want to participate in science, part of your responsibility is going to be communicating clearly, right? Communicating your information as clearly, concisely, and understandably as possible. What you don't want to be, for everyone who knows Lord of the Rings, the "you shall not pass" line, Gandalf and the Balrog or Balrog, whatever it is, and "shall" is sort of a weak. Don't use the word "shall." That's a stupid word. That was an inappropriate word choice for Tolkien. That's Douglas MacArthur, Winston Churchill, like. I shall not flag or fail. It's all gibberish. You will not pass is bold writing. Don't never say shall. It's a stupid word unless you're in law, and then it means you have a duty to. But that was just, Tolkien was a good writer, but not there. So again, the reason this is unfortunate, when you have this unclear, indecipherable Braille of science, where the whole world just like, look, I just need it to be convex so I can feel it and understand what it's saying. And you've converted science to its own alphabet, its own lexicon, its own sentence structures. The reason it's unfortunate is we don't actually get to benefit from it. Indirectly, sure, but not directly, right? The taxpayers who are paying that $41 billion, 42, whatever it was, billion dollars every year, they are not seeing that investment, right? They're not getting dividends off that investment. Not directly. So the idea is in your writing, in your communication, your correspondence, and your endeavors, your scientific endeavors, just heave open those gates and write clearly. Don't try to show off with big words, because all it does is telegraph insecurity. Clarity is the boldest writing that you can have. And so, again, what we have to do is communicate in the way that this kid understands. I'm guessing he's between the ages of 2 and 20. Let's call him 6. So that a 6-year-old, or as it says on the screen, a 6th grader would be able to understand it. And most people aren't doing that. I mean, the bulk of it, if you go to a student conference, I mean, you will sit in the audience and eyes glaze over. You have no idea what the person is talking about. And in their head, they think, aren't I smart? And then you'll watch somebody like Stephen Hawking. Well, he's dead now, but you'll watch one of his contemporaries, some peer, or even just read his books. Read a Stephen Hawking book, and it's written to like 6th graders. If you don't understand what Stephen Hawking is saying, there's a problem with learning of the English language. He's so clear, so understandable, and no one would argue that he wasn't a brilliant astrophysicist or whatever branch of physics. So the point is, for this class, for science in general, for whatever your career is, you have to let people in on it. You have to let them understand and communicate accordingly. So during the class, between now and the end of the semester, we're going to cover a lot of things. Traditional hypotheses. So whenever you're going to investigate a phenomenon, you begin by coming up with a hypothesis. I believe X, and then you test X, and then decide if you still believe it afterward. And the math of making that decision, it's like p-values, probability. We're going to spend a long time on that. I think I mentioned that on Monday. There are a lot of ways that modern stats, contemporary statistics, don't mitigate some of the problems, right? They don't avoid some of the problems of data manipulation and some of the major threats to honesty of the statistician or reliability of the data set. And so we'll talk about some of those things. Some solutions to them, like Bayesian statistics. This is just, if you do one experiment, you have a single sample, you sample from a population. Let's say there's, I don't know, 1 million baseball players, and you test one team, right? You test a college team. You can't make inferences about pros and college teams in other states and little leaguers, right? You can't just say, well, this is true in baseball, right? And so Bayesian is this idea of summation of information. A single finding does not expel the truth or accuracy of another conflicted finding. They might go together in the end. It just sort of, it's constant updating. It's how we should all behave in life when we're introduced new information. Again, we'll spend a lot of time on p-values and standard errors a little bit, standard deviations, stuff like that. Where research should always begin is the question, though. What I said about having a hypothesis. You begin with a question in mind, and that question has to matter. And it can be about anything. So whatever you're interested in, that you're going to have questions. If you're interested in architecture or I don't know, Pokemon or basketball or fishing or whatever it is, you're going to have questions. The world's mysteries have not all been solved. We don't even know what most of the proteins do in the body, right? That there are so many more mysteries than there are answers. We have this dire shortage of answers in the world, and we have an abundance of questions, but people aren't really curious enough to ask them. And so what you want to do is at first be curious, and then be able to shape a question that is meaningful, one that people actually care about, a question that matters. And an easy way to decide whether a question matters is to wonder what the end user actually wants to know. If you are a physical therapist, right, you're doing research in physical therapy, the end user is a physical therapist working with a patient. What do they actually want to know? Does this therapy work better than that therapy? Is this one more dangerous than that one? Is this one safer? Or for this particular population, is it better than for that particular population? The end user would be some practitioner, or it could be a player or a coach. Whatever the end user is, focus on meaningful questions that would actually have some sort of effect. Now, if the end user is a physician, orthopedist or something, they may need an x-ray, right? They may need to see the hand, like, or what am I repairing? What am I up against? For this one, you could just see it from the outside, right? You don't actually need the x-ray to see the fingers are coming out of like the forearm. But the idea is you come in and your hand is all bruised up and you need to see if it's, all right, what do we need to do with this thing? And so you get them an x-ray. But the stats are sort of an x-ray of a kind, right? You are investigating something under the surface to come up with answers that are probably not what you would expect. Sometimes they are, but often they deviate from expectation. We'll talk about data gathering strategies a little bit, how to analyze, sort of beginning to end. We're going to go beginning to end, from the question to how you amass data on that question, to sort of cleaning of a data set, you're preparing data to be analyzed, and then analyzing and interpreting and how you phrase your sentences about them. But historically, there's a lot of lessons. And so if you know Princess Bride, that Peter Falk and Fred Savage, that intro scene where he's going to read him a book and he's like, but we're going to do the good parts version. That's what I'll try to do here is the good parts version. It's sort of the mediocre and good parts version. I'll skip over the pointless stuff is the best that I can do. But research, right? People think of research like, oh, big data and all, like it's not new. People have been researching for as long as questions could be asked, but we didn't really have the resources to conduct research. But 4th century BC, we're seeing some initial attempts to ask questions and come up with reliable answers. Aristotle, natural philosophy, right? That's his thing. The Aristotelian, like, natural philosophy. It's like this. It's like a mathy, inquisitive philosophy. It doesn't quite get at research, but it's reason, it's logic. There's some evidence there, and so. Once we get past that, we get into something closer to modern statistics, 17th century, so 1600s, political arithmetic. And I mean, this is a bunch of people wearing, powdered wigs and trying to figure out lifespans of their citizens. They're trying to figure out, how much food are we going to need, come winter, and what's our population going to be next year, and so that's political arithmetic. Is this initial census kind of data, but it's a little bit more sophisticated than a basic census, where you're trying to make predictions and understand the society that you're making and ruling and trying to preserve. But in 1906, right, Mark Twain, like Mark 2 fathoms, that's where he got his name. I think he was always shouting Mark Twain back to land to say it's 2 fathoms deep here. But in 1906, he said, there are 3 kinds of lies, damn lies, and statistics. So already, more than a century ago, people were manipulating statistics to be biased and try to get support for their biases. So this isn't new either. The New England Journal of Medicine, this is probably the top journal in the world. Year by year, depending on the metric, you might encounter some other journal that outcompetes it in some specific metric, but pretty much everybody would agree, New England Journal of Medicine, top journal in the world. Lancet is good, Science is good, Nature is good. I mean, there's a bunch of good journals. So this is the top. And I mean, 200th birthday, this thing has been around for a really long time. And early on in its life, the analyses that Mark Twain was talking about are remarkably different from what people are doing today. Back then, people were not doing ANOVAs and regressions, and they weren't the same analyses back then. Those have largely been invented. Contemporary statistics have been invented since then. But we're still up against methodological limitations. Mark Twain's line still applies today just as much, if not more, than it did back then. So the purpose of research, again, it's not for the sake of research itself. It's not research for the sake of itself, right? It should be to accomplish something, to illuminate something that you previously didn't know. It should be moving us down a road toward a better life, that our kids are going to have a better life than we had. I mean, that sort of environmental and medicinal and technological and all these domains, we should be making advancements, not just research for, oh, I did research, because that just sort of clutters everything up. But when we have sound research, when the answers are reliable, when we can trust them, that affects our beliefs, right? It gives us predictions. We all know that if you touch the fire, you burn your hand, right? So we learn to believe that there's pain here, and our behavior changes. If you get into something like meteorology, the weather reporter is going to tell you chances of showers or sunshine or fire, tornadoes now. And so they're going to tell you what's to come, what's outside, and that changes your belief about you go outside this day, and do you think it's going to rain? Do you think it's going to just whatever they say. That the Oscar Wilde quotation is from Dorian Gray again, but we can forgive a man for making a useful thing as long as he does not admire it. The only excuse for making a useless thing is that one admires it intensely. All art is quite useless. It's a brilliant quotation. It's essentially about what we're talking about. Statistics should not be admired, right? Statistics are useful. You better not admire your findings. Otherwise, you're going to come up with ways of defending it like an attorney in a very biased way, where no matter what guilt belongs to your client, right? Your claim, your hypothesis, no matter how guilty that thing is, you're doing your best to defend it. Like, that's terrible. That's misleading people. That is regression, and not regression like prediction modeling, but that is devolving our understanding of the world and how it behaves. So what we want to do is not cherish our findings, right? You cannot be connected to the outcomes that you get. So let's go back to the meteorology. All right, we have Will Ferrell as whatever his name, John Burgundy or Ron Burgundy or something that rhymes with that Burgundy. And so he says it's going to rain, right? A lot, hard, and sort of innuendo tone. If you had a picnic planned, right? I mean, okay, you better bring umbrellas or one of those like kind of giant camping ones, or just go indoors, change your plans, do something like that, because you now believe that it's going to rain out, and so your behavior changes, right? So the prediction, science begets predictions. Predictions affect our beliefs, and beliefs change our behavior. So this domino effect to go from scientific experimentation and the scientific process and dissemination to behaviors in all of us. All of our behaviors change, whether we want them to, whether we are aware of it. Our behaviors change. And so if he changes his mind and says, yeah, it's going to be moist and warm and whatever, or it's not going to be whatever, it's going to be dry out, now we go do whatever behavior we were planning on doing. But again, science changes our predictions, right? Predictions are what give us our beliefs. Our beliefs change our behaviors. So science to behavior, it actually matters, which is why it's so offensive when the researchers don't let anyone in on the process. It's this language of exclusion ends up benefiting the behaviors of a select few while excluding the life-enhancing decisions of others. And there are penalties if the science is incorrect, or if the beliefs are incorrect. If Will Ferrell says, whatever Burgundy says, it's going to be nice and sunshiny, and then you go outside and it's like apocalyptic. It's like California outside, so just apocalypse skies and lightning coming down on your clubs. I mean, that's dangerous, right? You're going to pay for that one with your life. You're probably not going to pay for most biased science with your life. You're just going to waste money and waste time and all of that. So let's say you're an athlete. I mean, most people in health and exercise science are going into some sort of physical therapy, occupational therapy, sport-related, athletic training, sport-related role. And if you are an athlete and you injure your shoulder, clearly, according to the picture, you're very happy about it. You love your injured shoulder. Your team isn't going to wait. It's not, okay, let's just cancel games for a while until Mickey gets back or whatever. Nobody's going to do that. They're going to just go on without you. And so we are all encouraged, especially at the pro level. Your next contract might be coming up, and if you're sitting out on the DL, that's going to affect your livelihood of how much money you can blow at a casino. So so if you're an injured athlete, you want to get back as fast as possible. So let's say there are 4 different people with what appears to be the same injury, and 4 different programs, right? This guy, they apparently detach his arm. That doesn't look like it belongs to him. She has a toilet bowl for a sling. He's sort of normal, and all of them are super happy about their injuries. And there's 4 different programs, and they're all given the same information. Well, let's say there's like 2 programs, and they get to pick. So program A, you're going to return to play 3 times faster than program B. If that's all the practitioner, the PT or whoever says, or the orthopedist or whoever it is, if that's all they say, is you're going to return to play, in 1 week as opposed to 3, everybody takes program A, right? So that information, which is based on science, right? So whatever experimentation and the history and crunching of data is what gives the practitioner that number, the prediction of how quickly they'll return. But if there's more information, right? It's like, well, program A is surgical. Yeah, you'll get back on the field in a week if it works, but there's also a chance it doesn't work, and you're permanently unable to participate, right? Now you look more like this. And oh, the tennis player just looks angry. She looks better than she was before. So in that case, you have more information to crunch, but all of this is going to come from scientific experimentation. It comes from data, and our beliefs, when a doctor or practitioner of some sort tells us a prediction about the effectiveness of a treatment, that comes from data. And you can do these same analyses. I mean, I have databases from hospitals, and I do work in that field. And if you want to look at health outcomes, that's something we can get into. You just have to be disciplined and good and stuff. But it's an amazing springboard into the clinical world if you've published on clinical physiology, clinical care of patients. So all of these time frames, if this doctor says you have 6 months to live, and it's delighted to report that. That's information based on a history of patients, and they've crunched those numbers. Now, in the crunching, there's a lot of stuff that will come up with that number. That's not a mean, right? Maybe it is, and that'd be a terrible way to deliver information. Here's the mean, but that doesn't really communicate to you, because you are an individual and unlikely to be the mean in most things in life. The mean is just this the summation of a population. I mean, it's this average, but it doesn't describe that many people. Most people are not the mean. And so even if it was just a mean, there's going to be a standard deviation. So you have 6 months to live, give or take 5 years. None of that information, most of the information gets reported in a very precise way that tends to, at the expense of accuracy. So think about like a cancer diagnosis. What do you do? There's a bunch of options, right? Are you going to do radiation? Are you going to do chemo? Are you going to do surgery? What is it that you're going to do? You have to have research ahead of that. And then we can go one step further and say, what's the likelihood, right? What are the odds that I'm going to get cancer? And there are the BRCA1 and 2 genes. These are like referees for breast cancer. BRCA stands for breast cancer. BR, breast, CA, cancer. So very creative, kind of being curious naming system, but that's helpful. BRCA, breast cancer. So breast cancer 1 and 2 genes. It's also a little bit harmful because genes don't just cause cancer, right? There are genes do specific things, code for proteins of, this is that'd be like saying your liver is the thing that gives you cirrhosis. Your brain is the thing that gives you Alzheimer's. There are your kidney is the thing that gives you stones or whatever. So these genes are not like calling them breast cancer genes is, while it's informative, it's a little bit misleading. But there are certain alleles, right? And you can test your genes and see if you have these alleles that associate very strongly with breast cancer. And so if you have these alleles, these referees of breast cancer become less vigilant, less effective as referees, and that lends itself to like an ump in the MLB or ref in anything else like that's a real sport. They pay so much attention and they're really good at their jobs. But a ref in wrestling, in professional wrestling, they're always turning their head and communicating with the audience while someone brings in like a folding chair to beat up the other guy and whatever. Those refs, part of the act is that they don't pay any attention to anything. That's the show. And that's not what you want for refs in your body. And so people, if you sequence your genome and it turns out you have these particularly risky versions of the BRCA genes, you have these mutations that are unlikely to be encouraging. And if it says, okay, the doctor comes out and instead of saying you have 6 months to live, right, they say your odds of having breast cancer are a 5-fold increase of the person I just tested right before you, right? They had nice, healthy, normal versions of these genes. And you have the alleles that associate with breast cancer. Now, there's a lot of information to take in and to think about. You don't just go, oh, I'm going to get cancer. Because a 5-fold increase, well, what does that mean? If the initial odds are 1 in 8 billion, that means there's one person alive, right, who's going to get this. It's a 5-fold increase. Okay, there's 5 people on the planet who are going to get this. I'm probably not one of them. I will flip that coin, right? I'll play that hand, whatever. But if your baseline odds are like 50% or something, and there's a 5-fold increase, now you have decisions to make. Angelina Jolie made that decision, and she did prophylactic mastectomy. But so if you're without cancer, right? She didn't have cancer, and she got her breast removed without actually having cancer. So you just have to make the most of the information that you're given, and maybe you'll make the right decision, maybe you'll make the wrong decision, but your behavior is going to follow information. Your behavior will follow statistical dissemination. Again, whether you think you're influenced doesn't matter. We all are. So that's how we make decisions in life. But we should be making decisions as accurately as possible, right? What we don't want to do is be influenced, have our predictions be manipulated by inaccurate data. And so if you look at, like, just Google puppy predicts Super Bowl, any zoo animal, just come up with a zoo animal. Puppies aren't really in, at least not in American zoos. I'm sure they're in like a zoo in, somewhere in, I don't know, Northern Africa or something. But whatever, just find an animal at the zoo and type it in and say predict Super Bowl, and you will find an output like this. Who will win Super Bowl, whatever the hell that is. I mean, I have a hard time taking football seriously, only because, well, for a couple of reasons, but mostly because of Roman numerals, right? We accepted and changed completely to Arabic numerals in 8300 or something. You can look it up. What are we doing with Roman numerals? This is so, I feel like I'm working with children when anyone does anything in Roman numerals. Terrible numbering system, which is why we got rid of it, like, 1700 years ago. But anyway, the idea is that whatever animal predicts the Super Bowl, you will see tons of it. So here's Gabby the sea turtle, predicts this year's, Super Bowl. And so these sort of oracles, these prophecies, this used to be an article. They took it down, but there were 16 different species, porcupines and grizzly bears, that are predicting the Super Bowl. And so it seems fair to wonder, at least it seems, applying appropriate scrutiny, it seems appropriate to wonder how they're doing it, right? Because this one was one of the most famous, this octopus, Paul. He predicted all 7 in 2010, all 7 of Germany's matches, right? So there's one article, there's another one. Did he predict his own death? Like, I mean, like, that's like him down. I mean, he's just like this squiddy octopus thing. I don't know what the hell the difference is. Before, the way he all of these animals, whether it's a turtle or a hungry dog or something, they just put 2 bits of food. So for an octopus, it's going to be some sort of mollusk, right? It's going to be a clam or an oyster or scallop or something. And they put one with, I don't know, a Patriots flag or whatever, and one with like a Buccaneers flag, whatever. They have like 2 different flags. I don't know if they can compete against each other in the Super Bowl, but they put 2 different flags, and there's just whatever one it goes up and eats, right? That's its prediction. The octopus has no idea what sports are. Maybe there's such a thing as aquatic sports in, you know, like the octa whatever sports. I doubt it, and they certainly don't know about human sports. But we have these. I'm sure Jack Redlow is a wonderful guy. I'm sure he's happier than I am in life, and you know, loving person and stuff. But his quotation here is, if Paula predicts the Giants and the Giants win, all I can say is it's an incredible question of how that happened. Is it just chance? And so he was talking about whatever this Roman numeral Super Bowl is. Obviously it's chance. I mean, this is so ridiculous. They're not predicting anything. They're just eating whatever food was closest to them. But you go one step further with the Super Bowl indicator. And what this is you listen to, you know, Tommy the tortoise, or, you know, like Geraldo the giraffe, or whatever. You listen to these predictions, and you say, now I know if the stock market is going to thrive in 2020, 2021, 2022 because of the SBI. If you type in Super Bowl indicator in Google, you get tons of these things, where the winner of the Super Bowl, depending if it's AFC or NFC, the winner of the Super Bowl determines what happens to the stock market for that next year until the following Super Bowl happens. And between 1967 and 1997, it was a 90.3% accuracy, right? There were 31 Super Bowls, and it got it right 28 times, right? Bull market versus bear market. So bear market, this collapse, the bull, the gain, the bear, the collapse, the bull, the gain, that you get it. And so did we have a bull year or a bear year, and who won the Super Bowl? And like 90.3%, that's really, really accurate. But the problem is of who's, and it's based on the Dow Jones, right? There's the NASDAQ and the Dow Jones, these averages. But you know, which conference is winning, it is pretty consistent. Which direction the stock market is going is pretty consistent. You know, we don't have that many bull years there. And so, but after 1997, the Super Bowl indicator, the consistency was essentially lost. But Paula, Jack's mysterious oracle, did get it right? Accurately predicted the Super Bowl. And then what should have happened, NFC team, what should have happened is the markets rally, and it's just massive victory for the you know, economy, and then it was like just an enormous crash. Like the stock market just dropped by a third. It was a massive crash. And then, you know, people started paying attention to this stuff and figuring out that maybe the Super Bowl winner has nothing to do with the economy. It's just chance. And especially when you look at, you know, the Buccaneers, what conference do you assign them to? They played in both. Same thing with Baltimore Ravens. They have these cloudy judgments, right? If they've played in both, and so it turns out you have to give it, if you want the Super Bowl indicator to work over a period of time, you have to give the cloudy teams their original appointment. But even just trying to follow it after 1997, we keep having these stock market crashes. This just doesn't work. I have no idea who won the Super Bowl this last time, but this is not a healthy economy. If the NFC won, that was not a good prediction. But so here, just so we can all watch the video to see how this is Rocky the octopus, and you know, who he's picking. I think that's what, Patriots and Giants or something. I don't know. Again, football, Roman numerals. I can't take anything seriously that uses Roman numerals. And that's who he picks. Right, New York is going to win the Super Bowl. So that's how people, and people take this stuff seriously. I mean, this isn't a joke. And the problem, and the explanation more than the problem of taking this seriously, is that we all see patterns in the patternless. There's patternicity, right? There are words for this, or apophenia, words that mean seeing patterns and trends in things that have no trends and have no patterns. These things don't matter. So everybody probably sees like a T-Rex, like Jurassic Park is there, and it looks like maybe there's some little baby dinosaurs nursing. I don't think that's what happened with eggs, but there's, you know, at his feet, there's some little, you know, his roadies or something, his posse. And then there's the T-Rex running. We all see that, but that's just clouds, right? All it is just like moisture in the air. Or this, I don't know, we see aliens or something like that. Nobody just looks and says like, oh, it's just like some sticks and the angle you're looking at. People don't see that. What they see is like, here's a weird hunched, something between a Sasquatch and an alien, right? It's a Martian Sasquatch. And so that's what people see because of apophenia, because of patternicity. We see these patterns in things. Conspiracy theories, that's mostly what this is. So few conspiracy theories are actually even close to true. Like Kennedy was interesting because there was something there. Nothing else is even close to interesting. Lunar landing, conspiracy, all these things are just so hilarious. Like, because if a conspiracy is to sort of withstand the years and withstand scrutiny, it only takes one person to accidentally whisper it or mention it or write it down somewhere, and then the whole thing is blown. And like these conspiracy theories are all sort of silly. Casinos, this is what they take advantage of is apophenia, what's called the gambler's fallacy. It's random, right? Whether it's a slot machine, whether it's you're playing poker, whatever it is random. That is the nature of gambling. Random with slightly worse odds, just to ensure that the house wins. But the gambler's fallacy is the idea that I'm due, right? I've been on a losing streak for a while. I am due for a victory. That's the gambler's fallacy. And so people will continue to bet higher and higher, thinking they're somehow due for a win or if you flip a coin and you get 7 heads in a row and you know the coin is not weighted, right? You know it's not some hoaxy like magician's coin. And you get 7 heads in a row, you are not due for a tails, right? The next flip is a 50% chance of tails and heads, just like every other flip. And so the gambler's fallacy, casinos take advantage of that and people lose tons of money while they're there. In the 90s, like there was the static in the TV that like every boy who was 12 years old in the 90s is like, oh, I think it's the Playboy Channel. Is that a leg? It's static. Like I don't know what you're talking about. There's static there, and patternicity or apophenia. We see patterns, and we can do it with our ears too. If you're working at whatever this is that sells Halloween donuts, but if let's say it's McDonald's or it's Taco Bell or it's Krispy Kreme, it's whatever this is, those speakers are never that good. I mean, I don't know if I'm cutting in and out, but I mean, those things, they can never hear what you're saying, and yet they make sense of it. What you get in the bag is usually correct. It's sort of, and then they get it right. Like it does that sound, and then they get whatever was supposed to be in your bag. Patternicity, right? Michael Shermer, remember his name. He's an interesting guy, mostly because of this quotation, that he's one of the most connected to this sort of, he's very prolific. He has like 20 books. The first couple of books were about cycling. He's an avid cyclist. And so he published a couple of books about that, and he decided he needed to, do something with his life. And so he went on to, eventually get his PhD and write a bunch of books about belief systems. And his line here is really good, and it characterizes humanity very effectively. Humans are pattern-seeking, storytelling animals, and we are quite adept at telling stories about patterns whether they exist, right? So it doesn't matter if these patterns are there, we're going to find them and tell stories and make something of them. Computers aren't as good at this. They're getting better. The facial recognition on whatever social media and Facebook and iPhones but the CAPTCHA, where you just whatever R6H, it looks like the word rhododendron to me, and so like even that is a pattern that I'm looking at and it's not there. But that actually isn't the letters either. I mean, there's just like swirls, and then we decide that that's what it says. And although I always get those wrong, but these or like play Pictionary, and you draw pictures, and everyone's horrible. Every picture ever, it's like a picture of a koala or something, and it just looks like it's just like a circle with some lines on it, and people get it right. Computer would have a hard time figuring out koala. A Picasso, we all know that's a person, more or less. It's a person. That person would be. I would advise her to get her BRCA genes tested. I mean, that does not look like. I'm guessing she has the wrong mutation, but. A computer, they're going to figure out that that's a person. No, there's the hands, and there's where the BRCA genes are messing up. And, here's the nose and the eye. We can all identify that stuff, but computers are not very good at that. They don't see patterns in the way that we just predict patterns. And so it's one of our biggest handicaps is this idea that as soon as we observe the clouds in the sky, as soon as we observe a any sort of information that arouses suspicion or arouses a pattern or some sort of anything, we run with it. And that's the problem of all these, like the world is ending predictions, is they're just, I mean, yeah, there are patterns and I can see the patterns too, but like it never happens. You know, it just, the world just keeps spinning. I mean, NASA had to come out and say, I mean, California may be burned from the map soon, but I mean, the world just keeps going after all of these predictions. You can find hundreds of these things, and they were all over. I used to drive back and forth between California and Oregon, and there are just billboards that say the world ends on this day. And I remember they pay for, you know, the month or 2 months or whatever on the billboard. I remember driving after that day, and the billboards are still there. But NASA had to come out and say, you people who think the Mayan calendar has something to do with an apocalypse, please stop it. Like NASA had to come out and do public commentary because people are so inclined to make predictions on false information. This is just like, I sort of feel bad for the guy, for Harold Camping, for his getting so much scrutiny. I mean, he maybe shouldn't have been so public about these predictions and so certain about the date and having that date be so soon in the calendar. We're not going to watch it, whatever, but that's him making his prediction. But again, casinos, it's getting very advanced, right? The casinos are getting very advanced here, and point spreads, becoming like point spreads for basketball or football or whatever. And I will teach you during the semester, I will teach you how to do prediction modeling of statistics. What team is going to win? Well, let's do a logistic regression. What's a point spread? You know, how many points? Maybe a negative binomial regression or Poisson regression. Could be linear. Depends on the nature of the question. And but to make these point spreads yourself, and maybe you can outcalculate the people who made them, and you can come up with better odds. There are times when the lottery is actually, like, serious statisticians, much more serious than I am, have figured this out. There are specific times when buying lottery tickets, like buying a bunch of them, is actually on the verge of being an investment where you're likely to, you know, come out ahead. I didn't, you know, follow it for too long. My undergraduate stats professor, it was at Willamette up in Oregon, and he actually designed the Oregon lottery system. So I've been intimately familiar statistically with Lotto since I was an undergrad. But look at these lines of people who they think they're going to win. And the best line about Lotto that I've ever heard is when I was living in Connecticut. I was doing my PhD at the time, and I had this 45-minute drive there, 45-minute drive back, 4 or 5 days a week, and NPR would be playing in the background, and this guy came out talking about the lotto. It was this huge, you know, lottery, mega whatever, and he said, you know, the odds of winning are the same whether you buy the ticket. Doesn't matter. Your odds of winning are the same. And in a practical sense, that's true. In a mathematical sense, once you buy the first ticket, it goes from literally impossible to figuratively impossible. But going from ticket 1 to ticket 2 to ticket 3 to ticket 4 doesn't change your odds of winning in any, like, mathematically calculable degree. And everyone seems to know this. Like, look at the buildings in Vegas. Look how fancy these things are. How did they get their fanciness? How did they amass so much wealth to be able to erect such extravagant buildings? By taking the money of people who think they've figured out gambling. They've figured out how to crack the random code. You know, these slot machines, and in a graduate physiology class, I talk about the brain chemistry in a slot machine. It's fascinating, but the neurochemical cocktail that's affected when you're pulling that lever, and your brain is trying to make sense of what is random, of what is totally random, and your brain's trying to make sense of it. But nobody wins. And the gambler's fallacy is one of the modes through how Vegas and Reno, which I actually like Reno, it's cute, it's quaint. But one of the ways that they take your money, the other one is just let you win a little bit, so that people say, like, oh, you know, I know most people lose in Vegas, but I actually, last time I was there, you know, I won $200 or whatever. That's very much on purpose. It's to get people to think they're winners, so they come back later and lose $10,000. It's the $9,800 loss after the $200 win, the net, you know, loss that where they build all their buildings. So the people who make $200, that's what Vegas is for. But compared to this false information of generating false predictions, which generate false beliefs, which generate terrible behaviors, or at least financially bankrupting behaviors, Martha Stewart did it right. I mean, she went to prison, but she did it right? She used insider information, real information, and withdrew a ton of her stocks. It was about to collapse, and she saved like 46 grand. And then she goes to prison. Insider trading, you're not allowed to do that. But she had real information, and she made the most of it, and sort of made the most of it. And so the goal for this class and in life of how to think, how to make predictions, how to act on those predictions, how to behave, is to get Martha Stewart level quality, accurate information, and then make ethical choices with it. Because research, right now at least, research is the only way any of us knows how to update our understanding of the world, right? Make better predictions. I mean, think about just 1,000 years ago. If somebody was dying, I mean, George Washington was killed by a bleeding, right? I mean, this is not that long. This is in America. This is the United States, and George Washington is killed because people are like balancing his humors. Our understanding of medicine and science is relatively current. Our undertaking is pretty old. Our understanding is relatively current, but we're still sort of silly today in what we believe and what we know. And I mean, medicine is as rudimentary as you can imagine. In 100 years, what we're doing today in hospitals and in clinics is no more advanced than, make sacrifice virgin for have healthy crop, like this guy. That's not an experiment you can ethically run. No institutional review board is going to approve, like, okay, we're going to randomize 3 corn farms, right? These fields. This one, we sacrifice a bunch of virgins. This one, benign neglect. This one, we use, whatever, nitrogen and miracle grow stuff. Nobody is going to run that experiment, because it's just you're taking innocent lives, presumably innocent lives. But we have to address questions with science if we want any actual understanding with them. And that is everything for today. I think we're still in the time limit. All right, how are you guys doing? Was that just way too fast and explosive?
Yes, and
It's
no.
okay.
I mean, you have the recording for eternity. As long as electricity exists, you'll have the recording. I'll post it a little bit later today on Canvas, and so you can go back and pause and play and pause and play. But again, just remember that Christopher Hitchens line where if you don't have a drink in your hand, it's your own fault. So just make sure you take advantage of the resources that are available, the resources that are posting, and if you want to do the reading, and hopefully you can stay current, right? Stay up to date with the information as it's coming. Okay, if anyone has any questions, let me know. And otherwise, we can just, click the leave button.
All right, one more thing. So we're gonna use a program called SPSS for the labs. I'm working right now with the help desk to get the downloader emailed to me. Once I get the installer emailed to me, then I'll send it out to all of you. You'll all download it and then individually call the help desk and they'll give you the licensing number. That's going to be the easiest way to do it. Otherwise, it's kind of a shit show.
Really good point. The earlier you can get SPSS, the better. Every semester that I've taught this in the past, this is the first time that I've ever actually had support. And what better person to get than Nathaniel, who does a ton of analyses, has been tutoring for this class ever since he took it. You like taught it while you were taking it. There's like a day where I couldn't show up, and I walk in like halfway through class, and Nathaniel has a slideshow up, and he's lecturing. I think I don't know. I don't know if that was a semester after you took it or if that was like you were a student
I
at the
think that was
time.
the semester after I was doing it. Yeah.
Okay. But we're so lucky to have Nathaniel with us for this semester, this class, and I mean, it really is. If you can publish, it's massive on your resume. It doesn't appear on your transcript, but man, it's just your transcript is like a plain bagel, and then research is just lathering on whatever the salmon or the jelly or whatever it is that you put on a bagel.
Yeah, especially with grad schools, that's what they're looking for. I mean, they're academics, so they're looking at your academia.
Yeah.
They don't really care what you did for, I worked at the mom and pop shop as much as I care. Eager to
Yeah.
hear about that, but they don't
Yeah.
really care about that. They prefer the research. They prefer.
Yeah. Can you produce?
Background. Yeah, correct.
Yeah, yeah. Okay, I can see by your GPA that you can sit in class and take a test. Can you produce though? Like if I give you the pencil or the program or something, can you contribute to the world? And so that's what grad schools are often looking for is that transition from passive student to active participant in like science and society. And GPA says that you can do the student thing. That doesn't say that you can do professional contribution to life. If you have a publication or two, that's tons of evidence. And so that just checks that box with a bold, like one of those, it's like one of those serious Sharpies, like a marks a lot marker. And so, yeah, listen to Nathaniel's kind of feedback and guidance on getting started on that process and follow through. All right, should we like do this stuff and then leave? All right, it's hard to lecture when like I turned all of the screens off, all the like the visuals off, so I couldn't see anybody's reaction, and so I'm just looking at I feel like I'm alone in my laundry room, and so it's hard to it's hard to lecture with any enthusiasm. But all right, I'll see you sort of on Friday.
Thank you.
Thank you.
Yeah.